Okay, we're going to determine if this integral here converges or diverges. We have it from negative infinity to 0, and it's 1 over 3 minus 4x. The way we do this is that we first have to check if whatever variable we have here, which makes the denominator 0, is within our bounds. So in this case, what makes the denominator 0? It would be if x equals 3/4. The 4 cancels out with the negative 4, and you're left with minus 3. 3 minus 3 is 0. So we can't have 0 in the denominator when we're integrating. Otherwise, we would have to split it. So is 3/4 within our bounds? No, it's not within our bounds, because we're integrating from negative infinity to 0. So we're good. We don't have to split this into two different integrals and take the limit for each one. So we just have to do the limit for this thing. The limit as t approaches negative infinity from t, this is the variable that we're switching because we're letting the limit go to infinity of this variable. 1 over 3 minus 4x. How do we integrate this? Well, we let u be 3 minus 4x. U equals 3 minus 4x. The derivative of this, du, equals negative 4 dx. Since we're going to substitute dx, we solve for dx. Negative 1/4 du equals dx. So now we can make this substitution. We have the limit as t approaches negative infinity from t to 0. We make this substitution, we have 1 over u du, and this is multiplied by negative 1/4. The way we solve this is, you can imagine, this negative 1/4 is outside anyway. 1 over u, when you integrate that, that's just the natural log of the absolute value of u. So we got a negative 1/4 being multiplied to that. U, let's go ahead and plug that back in. It's 3 minus 4x. Negative 1/4 times natural log of 3 minus 4x. When we integrate and we have these bounds, we plug in the top and subtract from that, plugging in the bottom. And this is all still taking the limit, remember. Limit as t approaches negative infinity of this thing. So on one side, we're going to get an actual number, as you can see, because we plug in 0. So we get an actual number, but we still have to plug in the other side, because we don't know if it converges or diverges still. The other side to still be infinity, and even if it converges, we still have to solve the other side to see what it converges to. So, okay, let's do it. Negative 1/4, we've got the limit as t approaches negative infinity of the natural log of the absolute value of 3 minus 4 times 0. And from this, we are subtracting when we plug in t. This limit is to the entire thing, so it's also to this. Minus negative 1/4 natural log of the absolute value of 3 minus 4t is what we're going to replace this x with. So here, we just get this number. We get negative 1/4 natural log of 3. This becomes 0, and so you just get absolute value of 3, which is 3. You are technically taking the limit of this entire thing, but when you take the limit of something which is just a number, it's just a number. When you take the limit of this over here, you do have to plug in the negative infinity into this t. So what happens when you plug in negative infinity and multiply this by negative 4? Because this is negative 4 right here. You get a positive infinity. So whatever happens, you already have a positive infinity here. You have positive infinity because you're taking the natural log of positive infinity. And the natural log graph goes like this. It may not seem like it's going up to infinity in the y direction, but it is actually. There is no horizontal asymptote. It just keeps going on and on and on and on and on forever. So the natural log of infinity is infinity. So this diverges. Diverges because we're adding infinity.